Now, my dear students, let's continue with the exercise 13.2. So we had stopped at question number 7, so we'll continue from question number 8. So in this question, what we have here is in a hot water heating system. So let it maybe a machine, okay, a machine or a geyser and any system. So something like maybe this is the system for us, that's a machine. There is a cylindrical pipe of length 28 meters. So inside the machine we have one cylindrical pipe, maybe through which the water is flowing, and as the water flows, the pipe actually heats the water and then of course flows out the hot water, whose length is 28 meters. So once we have the pipe in this position, then of course we can call it as length. But if we place it upright, then that just becomes the height, especially for a cylinder. And diameter is 5 centimeter. Find the total radiating surface in the system. Find the total radiating surface in the system. So the total radiating, since this is a pipe, please remember that this surface will not be there because it is a pipe. So the total radiating system is actually what? The curved surface area only, isn't it? The total radiating system is actually the curved surface area. Because for example, if this is our pipe, so we'll have this holes through which the water will flow. So the radiating system will be the curved surface area only, this curved surface area only. So we'll have to find out the curved surface area. Length is given in 28 meter, which is considered as the height. So 28 meter, we can just convert that to one common unit. So I'll convert 28 to centimeter, meter to centimeter. So I'll have to multiply 28 by into 100. So I'll have 2800 centimeter. Diameter is given to us 5 centimeter. So radius will be diameter by 2 centimeter. So let it be as it is. Okay. So let's find out the curved surface area. So find the total radiating surface. So total radiating surface. You can bring out your pen, paper, and then you can start writing down. That will be curved surface area of the pipe. So the curved surface area of the pipe, the formula is 2 pi r h, twice of pi r h. So let's calculate that quickly. Twice of pi r h. You can start noting down. So that's going to be 2 into 22 by 7 into radius. Radius we consider as 5 by 2 into height or the length of the cylinder. So that's 2800 centimeter into centimeter. So that's going to be centimeter square. So we have 7 4s are 28, 2 zeros. 2, 2, 1s are 2, cancels. So we have 22 into 5 into 400 centimeter square. So 22 into 5 is 110 by 400 centimeter square. So let's find out in anything given in the question total. Of course we can leave it with respect to centimeter also, but let's find out with respect to meter. So if I want to convert this centimeter to meter, 110 into 400, we have centimeter square, that is centimeter into centimeter. So if I want to convert to meter into meter, I have to divide 1 by 100 meter for this, and again 1 by 100 meter for this centimeter. So that's going to be 100 into 100 meter square. So 2 zeros, 1 0, so we have 44 by 10. So that's going to be 4.4 meter square. So that will be the surface area, total radiating surface of the system. Okay, so yeah, those who wish, you can pause the video and then note down. All right, fine. Let's move on then. Let's continue to question number 9. We'll try to finish up this exercise as quickly as possible here in this particular video. So question number 9. I believe all of you have brought your textbooks along with you. So this is from the NCERT textbook only. So I'll just dictate. I believe all of you have your book. That is question number 9. The first question is find the lateral or curved surface area of a closed cylindrical petrol storage tank. But they have clearly given that even though it is mentioned closed cylindrical petrol tank, but I believe that they are saying, even though it's close, since they are saying to find out, telling us to find out the lateral or the curved surface area. So I think the question is very clear here, curved surface area. So we'll stick to that only. So to find out the lateral or the curved surface area of a closed cylindrical petrol storage tank that is 4.2 meter in diameter. So diameter is 4.2 meters. So our radius R will be 4.2 by 2. So that's going to be 2.1 meter. And height H would be 4.5 meter. Again, I repeat, even though it is mentioned that it's a closed cylindrical petrol storage tank, it's very clear in the question, find the lateral or curved surface area. So I think there's no doubt about that particular question. So let's find out. So that's going to be easy. Curved surface area would be twice pi RH. So that's going to be 2 into 22 by 7 into radius 2.1 into height 4.5 meter into meter. So that's going to be meter square. So there are many ways in which you can calculate. You can take the decimal and simplify also. So okay, I'll just take the decimal, that is 7 into 2.1. If you're not very comfortable with decimal system, you can just bring down the decimals by dividing by 100. By dividing by 100, so after that we can just calculate 7 3s are 21. So 44 into 3 into 45, and lastly we can just put back the decimal once our calculation is done. So 44 into 3 into 45. 44 into 3 into 45. So that's 3 4s are 12. Only 3 4s are 12 plus 13 into 45 by 100 meter square. So what should be 132 into 45? You can just calculate quickly. 132 into 45. 132 into 45, you can just calculate. I believe, I guess you'll have 5940 by 100 meters square. So 1010 we can just remove here. So we will have 59.4 meter square. So that's the lateral surface area of the closed cylindrical petrol storage tank. Okay, I guess that's done. Now the interesting part is the next question. Next part, sub question. That is number 2. Sub question number 2(9). Here the question says, how much steel was actually used? Okay. Let the actual steel used be X meters. Let the actual steel used be X meters. How much steel was actually used if 1/12 of the steel actually used was wasted? Since 1/12 of actual steel use was wasted. 1/12 means what? That is 1/12 of X steel used is wasted, which is 1/12 X. So this is the actual, this is the steel that was wasted. So how much of steel was actually used? How much of steel was actually used? So the total area of steel used is actually what? X minus 1/12 of X, because this is the actual total, actually the entire steel which was being brought and then started using. But in that process what happens is 1/12 of the actual steel use actually was wasted. So how much was actually used in our preparation of that tank? That's going to be from the x meters, this much is wasted, that is 1 by 12 of x. So the remaining from the x, 1 by 12 of the steel was wasted, so that's going to be, by simple calculation, 12x minus 1x, so that will be what, 11x minus 12 is the steel that was actually that was used. So this much steel was brought. In the process, maybe a slight part was actually wasted, so we have a little part of the steel, this much part of the steel. For example, like if this was the steel which was brought, this much was wasted. So let's say the total steel that was brought, let's say that the actual steel was brought was, let's say 100 meters, 10 meters lost. So how many meters was wasted? So how many meters actually did we use? 100 minus 10. So actually we have used 90 meters of the steel only. That is 11x by 12 meters of the steel we have used. So used means actually what? Used means that, it was like utilized in preparation of the closed cylindrical tank. In preparation of the closed cylindrical tank, which means that total surface area of steel used is actually what? Total surface 2 pi r h, 2 pi r plus h. This is actually the total surface area of the cylindrical tank. Now this total surface area of steel used is actually what? This was the amount of steel which is used. One part wasted, one part used. Bigger part used. That's going to be 2 into 22 by 7 into, what was our radius actually from the first part of the question? Our radius was 2.1 meters into 2.1 plus, what was our height again from the question? 4.5. So that's 11x by 12 is equal to 2 into 22 into 2.1. Just write 21, 7 into 1 decimal, I'll just bring down, into 2.1 plus 4.5, so that's 6.6. 6.6. Okay, let's just cross multiply. Okay, continuing with our calculation there. So 2 into 22 into 21, 7 by 10 into 6.6. So 2 into 22, 21 into 66 divided by 10. Another decimal I brought down here. 7 into 10 into 10. By cross multiplying, 12 is going up, 11 down. So then we have 7 ones are 7, 7 threes are 21, 11 ones are 11, 11 twos are 22. So that leaves us with 4 into 3 into 66 into 12 divided by 100 meters squared. So that's going to be 12 into 66 into 12 upon 100 meters squared. So how much will be that? 12 12s are 144 into 66 divided by 100 meters squared. So 144 into 66, how much will be that? 144 into 66. So that's 9504 divided by 100. So that's 2 decimals, 95.04 meters square. So this is actually x, which is what? X is actually what? The actual steel that was being used. Okay, so that's the question there. You can pause and then note down. Next, let's move on to the next question. That is question number 10. In the given figure, what we have is a frame for a lampshade. A frame for a lampshade. So that's something like a paper actually rolled. Okay, something like a paper which is being rolled. So something like this is the lampshade, for example. This is the lampshade, something like this. Okay, this will be question number 10. A lampshade it is to be covered with decorative cloth. A frame, the frame has a base diameter of 20 centimeter. The base diameter is 20 centimeter. 20 centimeters. So our radius R will be 20 by 2, so that's 10 centimeter. Fine. Height of 30 centimeter. Which height? That's the question. Height of 30 centimeter. Here actually they are talking of this height, 30 centimeter. A margin of 2.5 centimeter is to be given for folding it over the top and the bottom of the frame. A margin of 2.5 and 2.5 is to be kept over the top and the bottom. That means maybe if this is the part of the frame, this will be the top portion, this will be the bottom portion, which is to be left for what? Actually, for covering the lampshade. So how much cloth is actually required for covering the lampshade, for folding? So this part is like something like, suppose if this is the paper, and this part, of course, the upper part, very difficult. The upper part, of course, what will be something like, for folding on the upper part, and below part also we will be maybe something like folding. So this is actually the frame, that is the middle portion, and this portion that which I use, this portion that I use, this much, this is left actually for covering your folding the lampshade, and below also the portion which I've held. I mean, this portion is again 2.5, which is both the top and the bottom portions will be kept extra for folding over the lampshade. So that's the question here. So now the question is, how much cloth is required for covering the lampshade? So covering the lampshade, so of course we can just treat this as a complete a complete cylinder, isn't it? Simple as that, a complete cylinder. It's just that this much portion is left, this much portion is also left. So the total cloth required will be, if I can just get the total height of the cylinder, because like this part is left for folding. So why don't I just consider that 30 plus 2.5 plus 2.5, I'll get directly, isn't it? We can do it in parts also, but I don't think it's quite necessary. This part, middle frame, not the main part, this part is left for folding, this part is left for folding. So but before I fold, if I just look at the complete portion, it's a cylinder only. So if I can just add the middle frame plus 2.5 plus 2.5, directly I think we can have the height. Okay, so let's try by that and see what happens. So let's say total height including the top and bottom. Let's say this is a small edge, and let's say this is capital H. So let's say 30 plus 2.5 plus 2.5. Let's see. So that's going to be 30 plus 2.5 plus 2.5 will be 5.0. So that will be 35 centimeter. 35 centimeter. Radius is 10 centimeter. 35 centimeter. Radius is actually, of course, radius will be same. Radius is 10 centimeter. So let's try to find out the cloth required. Now cloth required will be what? See, the cloth required to cover this lampshade represents just the curved surface area only, because here I will not be using, because this will be already folded like this. This is actually folded, this portion is actually also folded. So, but I'm doing by assuming this to be the full length. So this portion I'm not leaving it out, just the total full length. So it acts as a cylinder and curved surface, because this portion is actually not folded yet. So I'm approaching a different view here. So in that case, it's just going to be, let's say, cloth required, area of cloth required. Area of cloth required will be curved surface area of the let's say entire let's say entire frame, not frame, yeah, curved surface of area of the frame including, that's what we are trying to do here, including the top and bottom. Let's see, top and bottom, so that's going to be 2 pi r h, 2 into 22 by 7 into 10 into, how much was this, 35 centimeters square, 7 ones are 7, 5, so 44 into 10 into 5, so that's going to be 220 centimeters square. I think the answer is correct, 2200 centimeters square. So actually what we can do is we can do it with part wise also. This part curved surface area, this part curved surface area, this part curved surface area. I'm not doing that. I've just added the whole part because it still acts like a cylinder only before I fold. So I'm doing before I fold, not after I fold. So if I can just assume this as a full cylinder, total length, this part too, as long as I've not folded, it's empty. It's just like a pipe only, no? Hollow pipe. So I've just assumed this as a full cylinder. Got the total height, radius is actually the same. So with that concept, we easily get the answer. So I think this will be, much more easier and better for us. Okay, the last question, let's try. The students of one school were asked to participate in a competition for making and decorating pen holders. Pen holders, imagine a pen holder, always imagine a pen holder. A pen holder, of course, will be something like this. I have one pen holder here. A pen holder, cylindrical in shape, no, a pen holder. A pen holder for making, okay, with a base. So you can see that the base part is solid, it's covered, but the upper part is hollow. So this is how it's going to look. So what will be the surface? So if I make this pen holder with a cardboard, where will I be needing the cardboard? I'll be needing the cardboard on the curved surface area and the flat surface. So I'll be using the cardboard in these two surfaces, that is the curved surface area plus the bottom circular part. Okay, let's keep that in mind. So what we have is each pen holder is to be made of radius r 3 centimeter and height h 10.5 centimeter. The Vidyalaya has to supply the competitors with cardboard. If there were 35 competitors, how much cardboard was required to be brought for the competition? Let's find out for one cardboard required for one pen holder. So that's going to be, as I mentioned, curved surface area of the cylinder plus area of the bottom face. So curved surface area of cylinder 2 pi r h plus area of bottom surface, that's a circle, pi r square. So that of course pi r common, 2h plus r. So pi 22 by 7 r 3 centimeter twice into h, height is 10.5 plus r again 3 centimeter into centimeter, that will be centimeter square. So 66 by 7 into 10.5 into 2 is how much? 10.5 into 2, 2 5s are 10, 2 1s are 2, 1 decimal. So that's 21. I'll just write 21 because 21.3 is of not 21.0, that's not needed, na? So that's 66 into 24 by 7 centimeters square. 66 into 24 divided by 7 centimeters square. So what will be 66 into 24 by 7 centimeters square? 66 into 24, 1, 5, 2 4s are 8, 1, 5, 8, 4. 1584 by 7 centimeters square. So the total area of cardboard required for, let's keep it like this, the total area of cardboard required for one pen holder is 1584 divided by 7 centimeters square. Let's keep it like this because we have to find out the total area of cardboard required for 35 competitors. So total cardboard area, total area of cardboard required for 35 competitors, competitors. Competitors will be 1584 by 7 into 35. 7 5s are 35. So that's 1584 into 5 centimeters square. So how much will be that? 5 4s are 20, 2 left, 5 8s are 40, 41, 42, 4 left, 5 5s are 25, 26, 27, 28, 29, 2 left, 7920 centimeters square. 7920 centimeter square. Alright, so that's the solution to question number 11. So that winds up this simple exercise on exercise starting point 2. Alright, so next we will do, I guess, cone exercises on cone, which is also not very difficult. So see you in the next video then. Okay, take care.